So good morning, welcome back. Happy Wednesday. Today, April 27, we're going to talk about graphing parabolas, which we've done already, but we have a new tool that we're going to add to our toolbox, which will make, which will give us the ability to graph parabolas, some parabolas that we weren't able to graph before, and then more problem solving, more word problems. Just looking ahead at the calendar in the coming days, on Friday is our review for test number 2, which is coming up on Monday. So we'll be here before you know it. Our second and final test of the whole semester is coming up on Monday. So I'll just scroll up a tiny bit here and show you that the first test we took was way back here, and it went up to class 13, which means that the next test is on everything 14 to 26. That's what this test is on all the way through the end of today's class, okay? Definitely not too early to start studying for Monday's tests. All right, and then looking ahead to the rest of the semester, after Monday's test, we got 4 more classes of new stuff, all things about fractions. And then we've got one final quest only on the fraction stuff. And then we've got a review day, and then our exam, our final exam is on May 18, which is a Wednesday. Right? So I think that's 3 weeks from today. I don't know. It's a tiny bit longer than a regular test. Yeah. Questions on the calendar? Okay, so we just gave back the quests. Now the median grade on the quest that we just took was 79, so that means half of you did better than 79, half did lower than 79. And there were some gaps that folks had that I wasn't aware that we had, and so I thought the results would be a little bit better than they were. What we're going to do is move blissfully along past the quest, because the stuff that I think we need to, the holes we need to plug are not going to come up in today's lesson. So we're just going to do today's lesson. I think we'll be okay doing today's lesson. And then on Friday, I'm going to come in and just talk about some of the things that I saw on the quest and ways that we can kind of get back on track with the conceptual errors that some of us have, okay? All right, so here we are on page 215, up here at the top. In this lesson, we solve word problems that involve maximizing or minimizing a quadratic equation. So the first time we're seeing those two words. Number 1, it says, have a look at graph A, whose equation is given there. Part A, using the graph, write the coordinates, 2 coordinates, of the x-intercepts. So just looking at the graph, we can identify the x-coordinates look like they're about how much? -6 and 1, but every point is represented by an ordered pair. So can you write 2 ordered pairs, because we have 2 points we're talking about. What's the far left one? -6, 0, and then 1, 0. Yeah, so just make sure when you're writing points, you give 2 coordinates. Okay, and then we know that the vertex is halfway between the 2 x-intercepts, right? So we would find where that vertex is by doing what to the 2 x-intercept numbers? The difference of them? Averaging them, right? That's how we find the number that's right in the middle. Okay, so let's write here. So averaging the answers we got in part A. So let's do that here. We'll get our answer for where the vertex is located. So x sub v means the x-coordinate of the vertex, and we're just going to average the 2 numbers we found. So -6 plus 1 divided by 2, right? Add up the numbers and divide by 2. And so that's a -5 on top and a 2 on the bottom, or -2.5, which sure seems reasonable looking at the picture, okay? Now that is just the x, but the vertex also has a y. I mean, you can ballpark the y coordinate by looking at the graph. Maybe it's -12 or so, but we want to find it exactly. So how would we find the y? Yeah, I would plug that -2.5 in for the x, right? Okay, and we'll do that soon, but we're not going to do that now. Number 2 says, it turns out there's an easy formula to find the vertex of any parabola. That -2.5, we're going to come up with that number in a much easier way, and it's not going to have anything to do with the x-intercepts. Here's our fancy new formula for today. It says that the x-coordinate of the vertex, that's our x sub v, is given by this tiny little formula, -b over 2a, where A and B are the same A and B we were using in the quadratic formula, right? A is the number touching which term? X squared. B is the number touching X, right? Same A and B that we had before. Notice that C doesn't appear in that formula. It's just negative B over 2A. In fact, negative B over 2A is part of the much bigger quadratic formula. I'm leaving out the stuff that's inside the radical, but would you agree that there it is? That's your negative B over 2A. Okay, so you already know the formula. If it's just a matter of ignoring everything that comes after the plus or minus. Okay, so let's use, this is 3 now. Let's use our fancy new formula to find the vertex of this equation, which is the one that we looked at up above. So the work is already written out, but we'll squeeze it in here. So don't look at the next line. So here's our formula, negative B over 2A. So we go negative, how much is B? It's 5. Divided by 2 times, how much is A? 1. Everybody see how we plug into the formula? And we get negative 5 over 2, which is exactly what we got before, right? Spiffy. Works for any parabola. This is how we can find the x coordinate of the vertex. You still need to find the y in the same way that Casey shared with us before. We still have to plug that number into the original equation. That's written out down here, plugging the negative 2.5 in for all the x's, and turns out it's about negative 12, which is what we had guessed by looking at the picture. So I don't have a shortcut to give you there. But we do have a nice new shortcut for finding the x coordinate of the vertex. And the really nice thing about this shortcut formula is, well, 2 things. Number one, suppose that these were not integer numbers, right? That negative 6 and 1, we just looked at it and we said, oh, we think they're really nice numbers, negative 6 and 1. But you guys remember we had another one where the answer was like negative 3.44 and change, and then like 1.44 and change. And the way that we would find the exact numbers was to use the big old quadratic formula, right? And so like we made it look like really easy here to just find x-intercepts. But finding x-intercepts is typically a big process involving the quadratic formula for most cases. And so if the only way we know to find the vertex is to first find the x-intercepts, well, this spiffy new formula is a lot better than that because it doesn't involve the big process of finding x-intercepts. Another nice thing about our formula is that suppose that you had a parabola that looked like this. Does this parabola have a vertex? Sure, it's this bottom point right here. The old method to find the vertex was to average the x-intercepts. Could we do it here? No, it has no x-intercepts. So our method just breaks down completely in cases where we don't have any x-intercepts. But this negative b over 2a formula still works. So for the first time, so we're going to do more graphing of parabolas today. I carefully chose the parabolas in the previous day when we graphed them so that none of them look like this. I had to give you ones where they all had x-intercepts because that was the only way we could find the vertex. But now we can do these kinds too. Okay, so coming down to number 4 is the vertex we found above on that parabola we were just looking at, the one that's already on your page. Is it the maximum or minimum point of the parabola? It's a minimum, right? This is a parabola that opens up, and so the vertex is down there at the bottom. We're on page 215. And so in number 5 here, it says it's often useful to be able to determine the smallest and largest value a quantity can assume. And so we're imagining we're going to see some word problems today, and they're going to have some common thread. So here it is. For example, companies try to minimize costs, right? That might be something your boss would want you to do. How can we minimize the costs? Okay, hey, look, this is a minimum point for parabolas that open upwards, right? So if somehow the cost function were represented by a parabola, then minimizing costs is the same problem as finding the vertex, right? And on the flip side, maybe we want to maximize profits. So perhaps your profit function is a parabola that opens down. And how would you maximize profits? What would you find? The vertex. So if you see the word maximum or minimum or biggest or smallest or highest or lowest or any synonym for those 2 words, that's our way of saying find the vertex, right? So in these word problems that you're going to tackle today and in the homework is not going to say find the vertex. It's going to say maximum or minimum or highest or lowest. And so you need to translate that right away to saying, oh, Ian is just asking for the vertex. Okay. All right. So let me, what I'm going to do here, we're going to skip the next page. I'm just going to jump to page 218. We're just going to run through some of these word problems. And I just want you to quickly skim the problem here, number one, and find the word that translates to vertex. One word in this problem says, find the vertex. Which one is it? Maximum. See it? Circle it right there. Write the word vertex right there. That's what it says. Find the vertex. Okay, I think there's a graph down below, so we're going to move to the next page. Take a look at number 3. Lots of words in this problem. See if you can find the one word that translates to find the vertex. Largest. There it is. Circle it. Largest. Find the vertex. That's what this problem boils down to. On number 4, skip down to the bottom of the problem. Find the word that says vertex. Lowest. There's another word in here that also says vertex. Minimum, you see, two for the price of one, right? So all of these word problems, they give you a hint, but they don't come out and say find the vertex, but they all mean find the vertex, right? So you could be looking for these keywords that mean find the vertex. And I also want to point out that our vertex formula is now this x equals negative b over 2a. But you've got a quadratic formula that you might be tempted to use. You see a quadratic equation. This guy here, you might say, oh, I'm supposed to use the quadratic formula. Well, that's not true anymore, not all the time. We've got 2 formulas now that are appropriate for quadratic equations. The whole quadratic formula, and then this vertex formula. You need to be really clear in your mind which one you're using. Okay, so we're going back to the place we left. So back to, let's go to 216, right here. 216. We've got a process written out here for graphing parabolas. It's quite similar to the process we wrote out a few classes ago for graphing parabolas, with a new addition here. So step 1 is to figure out if the parabola opens up or down. That's the same. Step 2 is to find the y-intercept. You said x equals 0. That's the same. The old step 3 was to find the x-intercepts. But the fact is there might not be any, right? There are plenty of parabolas which have no x-intercepts. So we're scratching that find the x-intercepts step. We're going to delay it and replace it with this new step 3. The new step 3 is to find the x-coordinate of the vertex by using our spiffy new formula right there. Okay, so that's the new step 3. Every parabola has a vertex, and you can always find the x-coordinate by doing that. And once you know the x, you can plug into the original equation to find the y. So you'll have ordered pair, both coordinates of the vertex. Then we are going to determine whether this parabola has 2 x-intercepts, 1 x-intercept, or no x-intercepts, just by looking at the answers to 1 and 3. So imagine that you have determined that your vertex is right here and that the parabola opens up. How many x-intercepts does it have? None. Imagine it's the same vertex, but now that parabola opened down. How many x-intercepts? 2. It's really easy just to imagine in your head. Just pretend. And if you've determined that it has no x-intercepts because it opens up, then you don't bother ever trying to find x-intercepts. But if it opened down, you say, oh, I know there's going to be 2 x-intercepts and I'm going to find them. Suppose that it was a vertex here. And this one opens up. How many x-intercepts? 2. And if it opened down? No. It's really quick. Last case, the only other possibility for the vertex, it could be above the x-axis, could be below the x-axis, or on the x-axis. That's the only other case. So here it is. If that's the vertex, actually it doesn't matter whether it opens up or down. How many x-intercepts does it have? It has 1, and in fact, you've already found it. It is the vertex. So there's nothing to do, no more x-intercepts to find in that case. Okay? And so the stuff written here in number 4, in bold, it just tells you basically what we said about, like just think about opening up or down and where the vertex is to determine if there are x-intercepts. And number 5 says, oh, sorry, back up here, number 4. The last part says, otherwise there will be 2 x-intercepts. Find them by setting y equals 0. That's the same process we had before. But it's just this extra step of, hey, don't bother looking for them if they aren't there. So spend a moment to decide whether or not they're there. Okay, so I think that's good. And then the symmetric point to the y-intercept is the same. So I am happy with that. We're going to skip 7. Let you guys just jump to the activity. It starts on page 218. So what's going to happen in this activity is you're going to be going back and forth between 2 kinds of problems. Some of them are going to be word problems, where the problem will translate to find the vertex. Every one of these is going to say highest or lowest or some synonym. So word problems that translate to find the vertex, and then graphing parabolas with our new fancy formula. Okay? All right, I will walk around. Let's see how far we can get.